Hello. Today we're going to be reading the Docker guides. Now, if you're watching tutorials, reading articles, you don't want to avoid reading the actual documentation for Docker. Super helpful. So, in the last video, we read the quick guide right here, this Docker overview, and we got to the bottom, two choices: install Docker or get started. Let's go to get started. And this is going to be a 10-part guide on getting started. Right now, we're just going to read it and learn as much as we can. Now, I'm going to hook up a friendly little iPad here so we can also take notes as we are reading. So, as always, I'm going to open QuickTime. That's going to allow me to create a new movie recording, and that's going to be my iPad. Okay, perfect. I'll put that to the side when we need it. So, overview of the Get Started guide. This guide contains step-by-step instructions on how to get started with Docker. This guide shows you how to build and run an image as a container, share images using Docker Hub, and deploy Docker applications using multiple containers with a database. Also, run applications using Docker Compose. Perfect. What is a container? A container is a sandboxed process running on a host machine that is isolated from all other processes running on that host machine. Okay, so you have a host machine, you have a process, and you have many processes, and these are all isolated. Perfect. So I'm going to go ahead and draw that. And maybe I can shrink this a little bit and share both screens at once. I can share something like this. How much can you see? Okay, so process. Now you have a host machine, and the container is the name for these processes that are isolated or probably contained from each other. So we have isolated processes here. That isolation leverages kernel namespaces and C groups. So these are Linux features, kernel namespaces, and C groups power this. Right? Features that have been in Linux for a long time. Docker makes these capabilities approachable and easy to use. To summarize, a container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker API or CLI. Okay, so let's just put the word image here. An image, let's say, helps us. Let me just zoom out. An image is helping us create one of these processes. And images are like blueprints for the container. Okay. Can be run on local machines, virtual machines, or deployed to the cloud. So it's flexible, is portable, can be run on any OS, is isolated from other containers, and runs its own software, binaries, configurations, etc. If you're familiar with chroot, then think of a container as an extended version of chroot. The file system comes from the image. However, a container adds additional isolation not available when using chroot. All right, so interesting. Great. So what is an image? A running container uses an isolated file system. This isolated file system is provided by an image, and the image must contain everything needed to run an application. All dependencies, configurations, scripts, binaries, etc. Okay, so this image is like a big old blueprint, and I'm going to make this blue. So it's a big old blueprint, and it can contain, a list of things, dependencies, configurations, scripts, etc. And these are containers. This is a container, this is a container, and these containers are processes. The image also contains other configurations for the container, such as environmental variables, a default command to run, and other metadata. Okay, so it just contains a ton of stuff. So a run command. Perfect. Next steps. In this section, you learned about containers and images. Okay, so yeah, we learned what an image is. An image is this blueprint that is used to create this container. A container is this runnable image, runnable instance of an image, and that's one of these processes. Okay, so part 2, containerize an application. For the rest of this guide, you'll be working with a simple to-do list manager that runs on Node.js. If you're not familiar with Node.js, don't worry. This guide doesn't require any prior experience with JavaScript. Prerequisites. You have an installed version of Docker Desktop. You have an installed Git client. You have an IDE or a text editor to edit your files. Next step, get the app. Before you run the application, you need to get the application source code onto your machine. Clone the get started app repository using the following command. Okay, so let's do that. I can totally do that. I'm gonna go into my programming folder where I put all my coding, and I'm gonna clone this. Get started app. Okay, so view the contents of the clone repository. You should see the following files and subdirectory. So let's just tree this, and I see this some spec, some source folder, and a yarn.lock. Spec, source folder, yarn.lock. Okay, let's see. Maybe I should have done a 1. How do I do this? What's the alias for tree here? Okay, so that's just the same as this. Okay, so build the app's image. To build the image, you need to use a Docker file. Docker file is simply a text-based file with no file extension that contains a script of instructions. Docker uses this script to build a container image. In the get started app directory, the same location as the package.json file, create a new file named Docker file. You'll use the following commands to create a Docker file based on your operating system. So for Mac, you need to run the following commands. Make sure you're in there. So cd into the directory, create an empty file called Docker file. Okay, so we can create a Docker file using a text editor, or I'll just put it to the side right here. Probably can't see that. That's probably enough. Add the following contents to the Docker file. Okay, so from node, Alpine, the working directory is /app. Do we have a /app here? We don't. Okay, so let's go to this Docker file. Copy this, paste it. So 18 Alpine, working directory is this app, and then copy ... not sure what that means. Run yarn install production, and then the command is node source / index.js expose 3000. Okay, perfect. So build the image using the following command. In the terminal, make sure you're in the getting started app directory. Replace path to getting started app with the path to your getting started. Okay, so cd again, and then build the image. So docker build -t getting started, and then a dot. Cannot connect to the Docker daemon. Is the Docker daemon running? So it is not running. So my Docker desktop is not open. So I'll go ahead and turn it on. Perfect. So I'll just move that to the side. Don't need that for now. That should have started the daemon. Looks like it's still loading. Once it's done loading, I'll play that. The docker build command uses the Docker file to build a new image. You might have noticed that Docker downloaded a lot of layers. This is because you instructed the builder that you wanted to start from the node 18 Alpine image. But since you didn't have that on your machine, Docker needed to download that image. Okay, so let's do this. My Docker is loaded. So it's Docker build -t getting started. So presumably, it's doing all the commands, right? So here's the command number 1 from docker.io/library node 18 alpine SHA. It's resolving it. I guess it's checking the checksum to see if it's the file that we are looking for. And then the working directory is this /app, copy, and then it's running yarn install production, exporting these layers, writing this image, and naming it to this. Okay. And that should be familiar because if you cat the Docker file, that is what we have here. Great. So after Docker downloaded the image, the instructions from the Docker file copied in your application, and use yarn to install your application's dependencies. The cmd, I guess command directive, specifies the default command to run when starting a container from this image. Finally, the -t flag tags your image. Think of this as a human readable name for the final image. Since you named the image getting started, you can refer to that image when you run a container. Did I -t that? What did we -t that to? So we did -t getting started. Okay, so Docker build, this is the tag that we put. The dot at the end of the Docker build command tells Docker that it should look for the Docker file in the current directory. Perfect. So next, start an app container. Now that you have an image, you can run the application in a container using Docker run. Run your container using the Docker run command and specify the name of the image you just created. So Docker run -dp 127.0.0.1 and then 3000 and then another :3000 getting started. The -d flag, short for detach, runs the container in the background. This means that Docker starts your container and returns you to the terminal prompt. You can verify that a container is running by viewing it in the Docker dashboard under containers or by running Docker ps in the terminal. The -p flag, short for publish, creates a port mapping between the host and the container. The -p flag takes a string value in the format of host container, where host is the address on the host and container is the port on the container. The command publishes the container's port 3000 to this IP on the host. Without the port mapping, you wouldn't be able to access the application from the host. Okay. So let's say we believe them, and we are going to do Docker run, detach, publish on this host 1.7001 3000, this 3000, and we're going to do getting started. After a few seconds, open your web browser to localhost 3000. You should see your app. Add an item or two to see that it works as expected. You can mark items as complete and remove them. Your front end is successfully storing items in the back end. At this point, you have a running to-do list manager with a few items. If you take a quick look at your containers, you should see at least one container running that's using the getting started image and on port 3000. To see your containers, you can use the CLI or Docker Desktop's graphical interface. Okay, so this is working, and I guess this right here that I got returned should be some type of container image, right? So if I do Docker ps, I get all of this mess, which is a lot of stuff. And then maybe if I do, hopefully, Docker ps this, nope, ps seems to be listing the processes. So I guess if I do Docker logs, that I get the logs for that container, and that container has using SQLite database at etc todos to-do.db and listing to port 3000. Okay, so if I visit this port 3000, I see this, and I guess this is not constantly running. Okay. Celebrate. Cool. So I can check them off. I can delete them. I have a running to do. Perfect. Magic, huh? Okay. So we have this Docker PS. We have the container name. This is what we saw when we did Docker PS, because what we saw was getting started. A little hard to read here, but that's a container ID. Getting started is the image name. The command is this Docker entry points, created 55 seconds ago. I guess that's the status. This is the port. That's exactly the port that we put in. And then it looks like it has a name, Quizzical Allen. Okay, next steps. Next, you're going to make a modification to your app and learn how to update your running application with a new image. Along the way, you'll learn a few other useful commands. So let's update the application. In part 2, you containerize a to-do application. In this part, you'll update the application and image. You'll also learn how to stop and remove a container. Update the source code. In the following steps, you'll change the empty text when you don't have any to-do list items to you have no to-do list items yet, add one above. In the source static JS app.js file, update line 56 to this empty text. Okay, so go ahead and copy this. And we are going to source static JS app.js. And we are going to look for, I'll look for text center. Many text centers, but here is one. You have no items yet, add one above. I'm going to go ahead and change that. Okay, so now I have duplicate tags. Did not mean to do that. So go ahead and delete this P, delete that closing P, save this, and now I've changed it. You have no to-do items yet, add one above. Okay, so build your updated version of the image using the Docker build command. Okay, so I'll just type this, I'll clear this to make it clear. Docker build -t getting started, and then I have to have the dot at the end. And is this going to be faster? Hopefully, so it doesn't download this. So this is presumably in some cache somewhere. Does all of these, does it run install again? Looks like it's resolving packages, still fetching them. So it's doing some stuff, even though I didn't make any changes to the packages. Linking dependencies. Okay, so you're going to start a new container using the updated code. I'll type this. As practice, I'm going to type it, docker run detach publish 127.0.0.1 and then at the 3000 here. So the 3000 here apparently is the Node.js default port, and presumably if I look at whatever is the Node.js file here, not sure where it would be, maybe source, probably index, and then if you look at this listen, it's listening on 3000. So I guess on my own computer I'm visiting it at 3000, and then in the container it's at that 3000 address. Okay, so let's do this again, docker run, and I'm going to do getting started. I have an error. Oh, and they knew I was going to have an error. Tricky, huh? Error response from daemon. Driver failed programming external connectivity on endpoint. Sharp Rosalind. So that's probably the name of my new one. It failed because the port is already allocated. Interesting. So, dual allocation. You aren't able to start the new container while your old container is still running. The reason is that the old container is already using the host port 3000 and only one process on the machine, and containers included can listen to a specific port. To fix this, you need to remove the old container. All right. So we can get the ID of the container with Docker PS. we use the docker stop command to stop the container, replace container ID with the ID from docker ps. So docker ps, docker stop. Once the container is stopped, you can remove it with a docker remove command. Okay, so ps, stop, and remove. So if you look at docker ps, it is this first one. It's the container ID. So I'm going to docker stop it. So I don't want it running anymore. And then docker remove. And if I do docker ps now, I have some other containers running, but these were made months ago. That's gone. You can stop and remove a container in a single command by adding the force flag to the docker remove command. For example, docker remove -f. Okay, next, start the updated app container. Now start your updated app using the docker run command. Okay, so docker run, detach publish, so that becomes second nature now. 3000, getting started. Refresh your browser, and you should see the updated text. Okay, let's do it. You have no to-do items yet. Add one above. Perfect. That's what we just did. Summary. In the next section, you'll learn how to update and rebuild a container as well as how to stop and remove. In this section, you learn how to update and rebuild a container as well as how to stop and remove one. Okay, so how to stop and remove was literally stop and remove, or remove with force. Next steps, you'll learn how to share images with others. Share the application. Now that you've built an image, you can share it. To share Docker images, you have to use a Docker registry. The default registry is Docker Hub and is where all the images you've used have come from. Docker ID. A Docker ID lets you access Docker Hub, which is the world's largest library and community for container images. Create a Docker ID for free if you don't have one. Let's just read through this. Might not actually do it. Create a repository. To push an image, you first need to create a repository in Docker Hub. Sign up or sign in to Docker Hub. Select the Create Repository button. For the repository name, use Getting Started. Make sure the visibility is public. Select Create. In the following image, you can see an example Docker command from Docker Hub. This command will push to the repository. So it's going to be Docker push Docker Getting Started tag name. So then you push the image. In the command line, run Docker push. Run the Docker push command you see on Docker Hub. Note that your command will have your Docker ID, not Docker. For example, Docker push your username getting started. Why did it fail? The push command was looking for an image named Docker getting started, but didn't find one. If you run Docker image ls, you won't see one either. To fix this, you need to tag your existing image you've built to give it another name. Sign in to Docker Hub using the command docker login -u, your username. Use the docker tag command to give the getting started image a new name. Replace your username with your Docker ID. So docker tag getting started, your username / that. Now run Docker push command again. If you're copying the value from Docker Hub, you can drop the tag name part, as you didn't add a tag to the image name. If you don't specify a tag, Docker uses a tag called latest. So docker push your username / getting started. So I guess number 3, on number 3, you're giving getting started a name, and that's going to be, so you're renaming this prefix, I guess, your username getting started from this Docker getting started. And then once you rename it, then you can push it. Okay, so run the image on a new instance. Now that your image has been built and pushed to the registry, try running your app on a brand new instance that has never seen this container image. To do this, you will use Play with Docker. Play with Docker uses the AMD 64 platform. You're using an ARM-based Mac with Apple Silicon, you will need to rebuild the image to be compatible with Play with Docker and push the image to your repository to build an image for the AMD 64. Okay, so open your browser to Play with Docker, sign in, select add a new instance. If you don't see it, make your browser a little wider. After a few seconds, a terminal window opens in your browser. In the terminal, start your freshly pushed app. So you can do Docker run, the same stuff that we've been doing, but then on the image. You should see the image get pulled down and eventually start up. You may have noticed that this command binds the port mapping to a different IP address. Previous Docker run commands published ports to 127.0.0.1. This time you're using 0000. Binding to 127 only exposes a container's ports to the loopback interface. Binding to 000, however, exposes the container's port on all interfaces of the host, making it available to the outside world. Interesting. For more information about how port mapping works, see networking. Select the 3000 badge when it appears. If the 3000 badge does not appear, you can select open port and specify 3000. In this section, you learned how to share your image by pushing them to a registry. You then went to a brand new instance and you were able to run the freshly pushed image. This is quite common in CI pipelines, where the pipeline will create the image and push it to a registry, and then the production environment can use the latest version of that image. Awesome. So that's exciting. We use Play with Docker. Never used that before, but that's a very interesting tool that allows you to play with Docker. Gives you the experience of having a free Alpine Linux virtual machine in browser. Super cool. Where you can build and run Docker containers and even create clusters in Docker Swarm mode. Cool. All right, so to summarize this video, we read through some of the Getting Started Guide, Part 1, Overview, Part 2, Containerize an application, Part 3, Update the application, and Part 4, Share the application. In the next video, we'll go through Part 5, Persistent DB, use bind mounts, multi-container apps, and much more. Thank you.